Hello students. In the last class so far we have started a little different question related to principle of mathematical induction. That is related to a divisible concept, division method. We have given the idea, last problem I discussed, and next question we have to show that 41 raised to n minus 14 raised to n is a multiple of 27. Is a multiple of 27 means it is a divisible by 27. So 27 let divide our 27 into some number you should get it. So 41 raised to n minus 14 raised to n is equal to 27 into some number. So this is a multiple of 27. Multiple of 27 under one divisible by 27 under one. So let us take just as usual procedure. Let us take this is a p of n. P of n is 41 raised to n minus 14 raised to n is a multiple of 27. Is a multiple of 27. Let us take this is the equation number 1 or statement number 1. So step 1 we have to show the statement is true for n equal to 1. So for n equal to 1 we have to substitute here 41 raised to 1 minus 14 raised to 1. So 41 minus 14 is nothing but 34. I'm sorry. I started 41 ಅಲ್ಲಿ 10 ತೆಗೆದ್ರೆ 30 ಅಂದ್ರೆ 1 and 4 ತೆಗೆದ್ರೆ 30. I'm sorry. Once again. I'm sorry for the disturbance. 27. So it is a divisible by or is a multiple of 27. I can conclude it is a divisible by 27 or we can say that it is a multiple of 27. So multiple of 27 of the number. So now come to the point. Therefore, what is our conclusion? P of n is true for n is equal to 1. Second, next step 2. Assume that 41 raised to k, assume that p of n is true for n is equal to k. That is p of k, what statements? 41 raised to k minus 14 raised to k is a multiple of 27. That is multiple of 27 under 41 raised to k minus 14 raised to k is equal to 27 into some number where m is any integer. Okay, so let us take this main point, second equation you can take is the main point for step 3. It's a very important point. Next we have to show in step 3 we shall prove that p of n is true for n equal to k plus 1 also. N equal to k plus 1 also. That is 41 raised to k plus 1 minus 14 raised to k plus 1. Consider this is a step. Is equal. We have to show that this is a divisible by 27. Is a divisible by 27 ಆಗಿದೆ. ನಾನು ಏನು ಮಾಡ್ತೀನಿ law of indices ಬರ್ತೀನಿ 41 raised to k into 41 raised to minus 1. So 14 raised to k into 14. So can I write it by using the law of indices? So from 2 you can write 41 raised to k can be written as 27 plus 14 raised to k. You can write this, you can take this to ಅದನ್ನು ಯೂಸ್ ಮಾಡಿ. So in 41 raised to k ಜಾಗದಾಗ ಇಟ್ಬಿಡಿ. So ಅದೇನೈತೆ ಬರಬಹುದು. So 27 plus 14 raised to k into 41 minus 14 raised to k into 40. ಇದಂದ್ರೆ ಇಲ್ಲಿ ಬರಬೇಕು because from 2 I have written from 2. ನೀವೇನು ಮಾಡಬಹುದು you can write 41 raised to k or 14 raised to k ಇತ್ತು ಒಂದು ಇದನ್ನ ಈ ಕಡೆ ಕಳಿಸಿ ಹಂಗೂ ಬಿಡಿಸಬಹುದು. ನಿಮಗೆ ಯಾವ ಚಾಯ್ಸ್ ಆಗುತ್ತೆ ಈಜಿಯೆಸ್ಟ್ ವೇ ತಗೊಳ್ಳಿ. So ಇದರಿಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. So 41 into 27 plus 41 into 14 raised to k minus 40 into 14 raised to k. So 41 into 27 plus ನೋಡಿ 14 raised to k ಎಷ್ಟು ನಾವು ಇಲ್ಲಿ 41 ನಾವು minus 14 41 ಅಲ್ಲಿ 14 ತೆಗೆದ್ರೆ ಅಲ್ಲಿ ಬಂತಲ್ಲ ಆಗ 27 so 27 14 raised to k ಹಿಂಗೆ ಬರೀತೀವಿ ಸಿಂಪಲ್ ಆಗಿ 41x minus 14x ಏನು ಮಾಡ್ತೀವಿ 27x ಅಂತ ಬರೀತೀವಿ ಹಾಗೆ 41 into 14 raised to k minus 14 into 14 raised to k ಹಾಗೆ so what is common in these two? It is common 27 you can take common 41 plus 14 raised to k. So what I conclude? So this is nothing but important point 27 into some number. This is nothing but 27 into this some number. Therefore I can conclude 41 raised to k plus 1 minus 14 raised to k plus 1 is a multiple of 27. Therefore, P of n is true for n is equal to k plus 1 also. Hence, by using the principle of mathematical induction, P of n is true for all natural numbers. I hope you got the point. This is the main point. Second equation I have used. So here 41 raised to k can be written as 27 plus 14 raised to k. So after simplifying, what I will get 27 into some integer. That's why what happened. So 27 into some number. That's why this is a term. That is nothing but this term is a multiple of 27 or a divisible by 27. You divisible by 27 ಅಂತ ಬರೀಬಹುದು. Exam ಅಲ್ಲಿ divisible by 27 ಅಂತ ಹೇಳಿದ್ರು ಇದೇ ಕ್ವೆಶ್ಚನ್ ಅನ್ನು ಬಿಡಿಸಬೇಕು. So multiple of 27 ಅಂತ ಬಿಡಿಸಬೇಕು. ಇದೇ ಕ್ವೆಶ್ಚನ್ ಅನ್ನು ಬಿಡಿಸಬೇಕು. So before going to solve next question, I am giving some idea about the some identities. So if it is like this, 5 raised to n minus 1. So if it is like this, is always divisible by 4. It is always a multiple of 4. Say for example, n equal to 1 to be 5 raised to 1 minus 5 is equal to 0. Divisible by 0. Another multiple of 0. So 5 square minus 5. 5 square 25 minus 20. So 5 cube minus 5 120. So 0 by 4 equal to 0. 20 by 4 equal to 5. 20 by 4 equal to 4 3s are 30 like this. So it is always a multiple or divisible by 4. And supposing 6 raised to n minus 6 is always divisible by 5. 6 raised to 1 minus 6 is equal to 0. 6 square minus 6. 36 minus 6. 30. 6 cube minus 6. 216 minus 6. 210. By 5. Divided by 5. Divisible by 5. Supposing 10 raised to n minus 10 is always divisible by 9. 7 raised to n minus 7 is always divisible by 6. Hinge. One tagabbedawa. This ಬೇಕಾಗುತ್ತೆ. ಈ next one. 5 raised to n minus 5 is always divisible by 4. ನಮಗೆ ರೈಟ್ ಹೇಳ್ಬೋದು 4 raised to n minus 4 is always divisible by 3. 4 raised to n minus 4 is always divisible by 3. For n is a natural number. N is a natural number. Suppose it is 16 raised to n minus 16 it is divisible by 15 always for any natural numbers. Now finally question, next question we will solve. Prove that 2 into 7 raised to n plus 3 into 5 raised to n minus 5 is divisible by 24. Divisible by 24. So statement P of n 2 into 7 raised to n plus 3 into 5 raised to n minus 5 is divisible by 7. Sorry, divisible by 24. Now multiple of 24 ಅಂದ್ರೆ ಹಿಂಗೆ ಬರೆಸಿ. So step 1. So let us take this is 1. Question 1. So step 1, for n equal to 1. N equal to 1 to 2 into 7 raised to 1 plus 3 into 5 raised to 1 minus 5. 2 into 7 14 plus 3 into 5 15 minus 5. So ಎಷ್ಟಾಗುತ್ತೆ 15 minus 5 10. 10 plus 14 24 is divisible by 24 itself. So conclusion, therefore P of n is true for n is equal to 1. Next step 2. Step 2, assume that P of n is true for n is equal to k. K is some natural number. That is P of k like 2 into 7 raised to k plus 3 into 5 raised to k minus 5 is divisible by 24. That is, it is divisible by 24 ಅಂದ್ರೆ 2 into 7 raised to k plus 3 into 5 raised to k minus 5 is equal to 24 into some integer. M is an integer. So this is the main point. So it is some simplify na jaan lekho na just na yaad karne ko hota. So next step 3, we shall prove that P of n is true for n is equal to k plus 1 also. So prove that it is true for n equal to k plus 1 also. So that is consider ಏನು ಮಾಡಬೇಕಂದ್ರೆ n ಇದ್ದಲ್ಲಿ k plus 1 ಬರಿಬೇಕು. ಯಾವ ಸ್ಟೇಟ್ಮೆಂಟ್? So 2 into 7 raised to k plus 1 plus 3 into 5 raised to k plus 1 minus 5. n ಇದ್ದಲ್ಲಿ k plus 1 ಬರ್ದೆ. It is divisible by 24. ಲಾಸ್ಟಿಗೆ ಆನ್ಸರ್ ಏನು ಬರಬೇಕು? 24 into some number ಬರಬೇಕು. ನೋಡೋಣ. So ಇದನ್ನ ಲಾ ಆಫ್ ಇಂಡೈಸಸ್ ಪ್ರಕಾರ 2 into 7 raised to k into 7 ಅಂತ ಬರೀಬಹುದು. ಪ್ಲಸ್ ಇದನ್ನು ಹಾಗೆ 3 into 5 raised to k into 5 minus 5. ಲಾ ಆಫ್ ಇಂಡೈಸಸ್ ಬರುತ್ತೆ. ಸೊ ಇದರಾಗಿಂದ ಇದನ್ನ ಇಲ್ಲಿಂದ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಕೊಂಡು 2 into 7 raised to k ತಗೊಂಡ್ಬಿಡಿ. ಇಲ್ಲೈತೆ ಈ ಪಾಯಿಂಟ್ ಅನ್ನು ಇಲ್ಲಿಂದ ಯೂಸ್ ಮಾಡಿ. ಸೊ ಇದನ್ನ ಕಲ್ಪಿಸಬೇಕು. This implies, so 2 into 7 raised to k can be written as 24m ఇది కಡೆ minus 3 into 5 raised to k ఇది ಕಡೆ plus 5. ಇದನ್ನ ಅಲ್ಲಿ so 2 into 7 raised to k ಅಲ್ಲ ಏನು ಬರೀಬಹುದು 24m minus 3 into 5 raised to k plus 5 into 7 plus 3 5s are 15 into 5 raised to k minus 5. So ಏನಾಯ್ತು ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 7 into 24m minus 7 3s are 15 into 5 raised to k 7 5s are 35 plus 15 5 raised to k minus 5. This one you can write here from 2. I have done this step. ನೀವೇನು ಮಾಡಬಹುದು 3 into 5 raised to k ನ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಕೊಬಹುದು ಅಲ್ಲಿ. So next 7 into 24m further simplification ನೋಡಿ minus 15 5 raised to k plus 15 5 raised to k cancel ಆಗ್ತದೆ. ಸ್ವಲ್ಪ ತಪ್ಪೈತಿ ನಾನು ತಪ್ಪೇನ. So 7 3s are 21 ಆಗಿದೆ. So 21 into 5 raised to k. So 21 minus 21 plus 15. 21 ಅಲ್ಲಿ 15 ತೆಗೆದ್ರೆ ಎಷ್ಟಾಯಿತು 6 5 raised to k plus 35 minus 35 minus 1. So 30. Okay, now further simplification. 7 into 24m minus ಇವೆರಡರ ಏನು ಕಾಮನ್ ಐತಿ 6 ಕಾಮನ್ ಐತಿ. 6 ಕಾಮನ್ ತೆಗೆದ್ರೆ 5 raised to k minus 6 5s are 30 बराबर अगर लिखना so because since I will write here 5 raised to k minus 5 is a multiple of 4 is a multiple of 4 or a divisible by 4 so I can write this implies 5 raised to k minus 5 can be written as 4 into some number p anta baridi am already use madi so you can write this is the main point if you are not getting this idea just recall that agala ee problem start madidda munche ಏನು ಹೇಳಿದ್ರು ಅದನ್ನ recall ಮಾಡಿ so 7 into 24 m minus 6 into I can write it is nothing but 4 into p where p is an integer so 7 into further simplification 24m 6 4s are 24 p so what is common in these things 24 is common so 7m minus p so 24 into some number we got it so what happened therefore 2 into 7 raised to k plus 1 minus plus 3 into 5 raised to k plus 1 minus 5 is divisible by 24 is divisible by 24 therefore p of n is 2 for n equal to k plus 1 also hence the statement is true for all natural numbers so point to be noted down so if you are not getting this point just recall this if you are not getting this point just observe 2 into 7 raised to k ಅನ್ನು ಇದನ್ನ ತಗೊಂಡ್ಬಿಡಿ 2 into 7 raised to k ಅನ್ನು ಇದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಷನ್ so ಈ ರೀತಿ ಬರುತ್ತೆ so ನೀವು 3 into 5 raised to k ಅನ್ನು ತಗೋಬಹುದು ನೆನಪಿಡಿ so it depends upon you so I will stop this question I hope you are getting the point so we will move to next question so ಇಲ್ಲಿ ಈ ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ ಸ್ಟಾಪ್ ಮಾಡಿ ಡಿಸ್ಕಷನ್ ಬಹಳ ಹಳಾಗುತ್ತೆ ನಿಮಗೂ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ so ಹಳಗೆ ಅರ್ಥ ನೋಡಿ ಅರ್ಥ ಆಗುತ್ತೆ so little bit different question I am giving you because of that reason so I am not giving that much importance regarding this question ಯಾಕಂದ್ರೆ ಇಲ್ಲಿಂದ ಹೊಳೆ ಅರ್ಥ ಬರೀಬೇಕು so be careful so next question we will to next point of question please prove that very easy question I will give 7 raised to n minus 3 raised to n is divisible by by 4 easiest way so let us take this the p of n 7 raised to n minus 3 raised to n is divisible by 4 divisible by 4 is 4 into some number so step 1 for n equal to 1 7 raised to 1 minus 3 raised to 1 is equal to 7 minus 4 is divisible by 4 itself. Every number is divisible by itself. Step therefore what is your conclusion? P of n is true for n equal to 1. Step 2 assume that P of n is true for n equal to k. K is some integer. That is 7 raised to k minus 3 raised to k is divisible by 4. That is 7 raised to k minus 3 raised to k is equal to 4 into some number. Okay. So let us take this the 2 and step 3 we have to move next step. We shall prove that P of n is true for n equal to k plus 1 also. That is consider 7 raised to k plus 1 minus 3 raised to k plus 1. 7 raised to k plus 1 minus 3 raised to k plus 1. So n might be 7 raised to k into 7 minus 3 raised to k into 3 by law of indices. So 7 raised to k ಅಥವಾ ಇಲ್ಲಿಂದ ತಗೊಂಡು 7 raised to k ಏನಾಗುತ್ತೆ 4m plus 3 raised to k. ಇದನ್ನ ಕಳಿತೀವಿ. Let us take this equation. ಅದನ್ನ ಇಲ್ಲಿ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. 7 raised to k ಅನ್ನು ಬರ್ಕೊಂಡ್ಬಿಡಿ. So it is nothing but 4m plus 3 raised to k into 7. ಇದನ್ನಷ್ಟು ಬರುತ್ತೆ. Next minus 3 raised to k into 3 because from 2 I have 10th step. So multiply 7 into 4m plus 7 into 3 raised to k minus 3 into 3 raised to k. 7 into 4m ಎಷ್ಟು 3 raised to k ಇಲ್ಲಿ 7 ದಾವೆ 3 ದಾವೆ 7 ರ 3 ದಾವೆ 4 7 minus 3 4 into 3 raised to k. So what is common in these two? 4 is common. So what left? 7m plus 3 raised to k left. So 4 into some number. Therefore, what is your conclusion? This is divisible by 4. So 7 raised to k plus 1 minus 3 raised to k plus 1 is divisible by 4. Therefore, P of n is true for n is equal to k plus 1 also. Hence, by principle of mathematical induction, the entire statement P of n is true for all natural numbers. So I hope you will get the clear idea. So about this question, just observe the point. ನಾವು ಮಾತಾಡೋದು ಹೇಳಾಗಿಲ್ಲ ಯಾಕಂದ್ರೆ ಅರ್ಥ ಆಗಿರ್ತೈತಿ. So step 1, step 2, step 3, because of that reason you have to keep the point. Next question. X raised to 2n minus y raised to 2n is divisible by x plus y. Is divisible by x plus 2. Let us take this the P of n. Let us take this is equation number 1. Step 1. For n is equal to 1, you have to show this two. For n equal to 1. So for n equal to 1 in x square minus y square is equal to x minus y into x plus 1 is divisible by x plus 1. I hope you will get it. X square minus y square is always a multiple of x minus y or x plus 1. So x square minus y square. So therefore conclusion, P of n is true for n equal to 1. Step 2. Assume that P of n is true for n equal to k. Okay, that is x raised to 2k minus y raised to 2k is divisible by x plus 1. This implies x raised to 2k minus y raised to 2k is equal to x plus y into some integer. M is an integer. So you point back up. Step 3 percent. Step 3 that we shall prove that P of n is true for n equal to k plus 1 also. That is, consider x raised to 2 into bracket k plus 1 minus y into 2 y raised to 2 into bracket k plus 1. So ಇದನ್ನ simplify ಮಾಡಿ x raised to 2k plus 2 minus y raised to 2k plus 2. So ಇಲ್ಲಿ ಏನು ಮಾಡಬಹುದು, x raised to 2k minus y raised to 2k ಅದರ ಯಾವುದರ ಒಂದು ಎಲಿಮಿನೇಟ್ ಮಾಡಬಹುದು. ಸೊ ಬೆಟರ್ ಏನು ಮಾಡಿ x raised to 2k ಬರ್ಬೋದು. x raised to 2k ಏನಂತ x plus y into m ಇದು ಈ ಕಡೆ ಬಂದ್ರೆ plus y raised to 2k ಆಗುತ್ತೆ. So let us take this is ಅದನ್ನ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ತೀವಿ. So you can write this is x raised to 2k. I'm sorry. x ಆಗುತ್ತದೆ y 2 ಬರುತ್ತೆ. x raised to 2k into x square minus y raised to 2k into y square. Law of indices. So x raised to 2k ಅಥವಾ y raised to 2k ಅದಕ್ಕೆ ಬರುತ್ತೆ. So now x raised to 2k ಬರ್ಕೊತೀನಿ. So I can write this x plus y into bracket m plus y raised to 2k ಇದು x raised to 2k from 2 I have into x square as it is minus y raised to 2k into y square as it is because from 2 I have 10th step ಏನು ಮಾಡಿಲ್ಲ x raised to 2k ಅಂದ್ರೆ ಅಲ್ಲಿ ಇದು ಬರ್ಕೊಂಡ್ಬಿಡ್ತಾರೆ. ನೆಕ್ಸ್ಟ್ ಇನ್ ಮಲ್ಟಿಪ್ಲೈ x plus y into m into x square ಇದು ಮಲ್ಟಿಪ್ಲೈ ಪ್ಲಸ್ ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ x square into y raised to 2k minus y raised to 2k into y square. So ಇದನ್ನ as it is x plus y into m into x square plus what is common in these two? It is common x square ಇಲ್ಲ y raised to 2k ಎರಡು ಕಡೆ ಕಾಮನ್ ಇದೆ y raised to 2k ಕಾಮನ್ ಇದೆ ಇಲ್ಲಿ x square ಉಳಿತು ಇಲ್ಲಿ y square ಉಳಿತು. So I can write x plus y into m x square plus y raised to 2k x minus y into x plus y. A square minus b square formula a square minus b square a minus b a plus. So ಈ term ಅಲ್ಲಿ ಏನು ಕಾಮನ್ ಇದೆ x plus y ಕಾಮನ್ ಇದೆ. So ಕಾಮನ್ ತೆಗೆದ್ರೆ ಏನು ಉಳಿತು m into x square plus y raised to 2k into x minus y. So what we got finally? What we got? X plus y into some number. So what I consider x raised to 2 into k plus 1 minus y raised to 2 into k plus 1. It is divisible by x plus 1. So it is divisible by x plus 1. Hence it is true for n equal to k plus 1. Therefore by using the principle of mathematical induction, this statement is true for n equal to k plus 1. So I hope you are getting my point. So this is the idea I am giving to you for a practice purpose, just to make a practice about these things. So by ending this question, I will conclude today's class. So we will continue the next class. We will continue more problems. You may know that problem now. That may almost known by tomorrow or day after tomorrow. That means 2 classes. 1 or 2 classes. 2 classes enough. In the other class, chapter mugideti. So ಇದರ ಮೇಲೆ 5 marks question ಜಾಸ್ತಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ which are before these questions ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಬಿಸಿದ ಕ್ವೆಶ್ಚನ್ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ 5 marks ಡೆಫಿನೆಟ್ ಬಂದೇ ಬರ್ತದೆ. So that one make a practice. So just keep practice. Till that, take care.